What if your grueling bumper-to-bumper 90-minute commute could shrink to a breezy 15? What if the soul-crushing traffic jams we all dread became nothing more than a bizarre anecdote you tell your grandchildren? Something from a bygone era. Sounds like pure science fiction, right? Well, hold on to your seats because Tesla isn't just dreaming about this future. They're actively laying the complex high-tech groundwork to make it an astonishing reality. So how exactly is Elon Musk planning to launch a flying car that will completely overhaul our world? And what will that future actually look like when it finally takes flight? Imagine this. You stroll into your garage and with a soft whir, sleek bird-like wings gracefully unfold from the sides of your vehicle. You lift off vertically, silently ascending above the gridlocked chaos below, soaring at an exhilarating 248 miles per hour. And it's not guzzling fossil fuels. It's running purely on Tesla's cutting-edge 4680 cells, propelled by a whisper-quiet electric jet system, derived straight from the same innovative propulsion tech powering SpaceX rockets. Industry analysts aren't just speculating. They're confidently predicting that the very first units could arrive in our driveways, or perhaps our vertiports, as early as 2026. And when they do, prepare for a seismic shift. Everything from your daily commute and the very design of our cities to the fundamental values of real estate is about to be flipped completely on its head. Stick with us because by the time this is over, you'll not only understand precisely how this dual-mode roadster-turned-aircraft actually works, but also why its price tag might not be as astronomical as you currently imagine, and what life truly looks like when the sky itself becomes your personal open highway. If the promise of groundbreaking future tech gets your adrenaline pumping, don't forget to tap that subscribe button right now so you absolutely don't miss the next big reveal that reshapes our world. Section 1. The technology that makes it fly all right. Let's metaphorically rip the hood, or perhaps more accurately, the fuselage, wide open and peer inside to truly grasp the engineering marvel happening here. This isn't just some concept sketch. It's a meticulously planned symphony of advanced materials, revolutionary power, and intelligent design. First, let's talk about the very bones of this machine, its structural integrity. Tesla's brilliant engineers aren't reinventing the wheel from scratch here. They're intelligently borrowing and adapting. Specifically, they're leveraging the same advanced aluminum alloys and carbon fiber composites that have proven their mettle in the extreme conditions faced by SpaceX's Starship program. Why is this so crucial? Because these aren't your average car materials. These aerospace-grade composites are engineered to be incredibly strong, yet astonishingly lightweight. We're talking about slashing the vehicle's overall weight to roughly 60% of what a normal car would tip the scales at. Think about that for a second. A vehicle with the inherent strength and crashworthiness you'd expect from a Tesla, but with a drastically reduced mass. This isn't just about making it easier to lift. It's fundamental to energy efficiency, range, and overall flight performance. Every gram saved translates directly into more miles flown, or more power available for other critical systems. These materials also offer superior stiffness and fatigue resistance, which are absolutely non-negotiable for an aircraft that will undergo countless cycles of stress during takeoffs, flights, and landings. The integration of these materials isn't just a clever trick. It's a foundational pillar supporting the entire ambitious endeavor, ensuring that the vehicle is not only capable of flight but also incredibly safe and durable for its intended lifespan. Next up, the beating heart of this aerial marvel, the power pack. We're talking about Tesla's stacked 4680 cells. Now, if you've been following Tesla's battery advancements, you know these aren't just incremental improvements. The innovative tabless design of these cells is a game changer. What does tabless mean for you? It means a dramatically shorter path for electrical current inside the cell, which in turn means significantly reduced internal resistance. The result? These 4680 cells pump out an astounding 5 times the energy of the older 18650s, all while generating substantially less heat. Less heat means better thermal management, which is absolutely critical for performance and longevity, especially under the high discharge rates required for flight. This massive leap in energy density and efficiency is precisely what makes a flying range of roughly 621 miles on a single charge not just aspirational, but genuinely achievable. Imagine the freedom that affords. This isn't just a battery. It's the core enabler of sustained long-distance aerial travel. The 4680 cells represent years of dedicated research and billions of dollars in investment, culminating in a power source that can meet the rigorous demands of vertical takeoff, high-speed cruise, and efficient landing, all within a compact and relatively lightweight package. Their ability to deliver consistent power output without excessive heat buildup is paramount for both safety and the operational lifespan of the entire propulsion system. Then there's the propulsion system itself. Forget those noisy propeller-driven prototypes that sound like oversized weed whackers, driving neighbors absolutely crazy. Tesla is taking a radically different approach. They're testing an array of small electric jet thrusters, essentially miniaturized Merlin engines but without the combustion and the need for kerosene. This is where the SpaceX synergy truly shines through. These aren't traditional jet engines that burn fuel. Instead, they operate on a principle of ingesting air, accelerating it magnetically through an advanced electric field, and then expelling it at high velocity out the back. The magic here is zero combustion and almost zero sound. Picture the subtle hum of a powerful electric motor, not the roar of a jet. This innovative design offers several profound advantages. First, the noise reduction is monumental, a critical factor for urban acceptance. Second, the environmental impact is virtually non-existent at the point of use with no direct emissions. Third, and perhaps most ingeniously, this system leverages multiple micromotors. Imagine 8 or 9 of these compact thrusters integrated seamlessly into the rear diffuser of the vehicle. This multi-motor array provides an incredible level of redundancy. What does that mean for you? It means if 2 thrusters were to somehow fail mid-flight, you still have more than enough power and control to continue flying safely and land without incident. It's a robust, elegant solution to one of the biggest challenges of aerial mobility: blending efficiency, environmental consciousness, and paramount safety into one revolutionary package. The precision control offered by individual electric thrusters also allows for incredibly fine-tuned maneuvering, crucial for stable vertical takeoffs, landings, and precise navigation in complex airspace. Now, let's tackle what might be the trickiest, most visually stunning part of this whole equation: the transition from road vehicle to aircraft. Picture this with me. You've just driven your sleek Tesla Roadster turned aircraft into an empty parking lot, perhaps a designated vertiport. With a simple tap on the large central touchscreen, you press the flight icon. What happens next is a choreographed ballet of advanced robotics and engineering. The wheels, designed for ground travel, smoothly tuck themselves away into the undercarriage, streamlining the vehicle for aerodynamic efficiency. Simultaneously, the signature gull-wing doors, or perhaps, more accurately, gold-wing doors as some have called them for their elegant opening, seal tight, creating a pressurized, quiet cabin environment. Then, with a sophisticated grace, powerful hydraulic arms extend the multi-jointed wings which were previously folded compactly against the body. These wings articulate and lock into their flight configuration, a process that's both mesmerizing and remarkably quick. A rapid, comprehensive 30-second diagnostic sweep runs through all flight systems, verifying everything is optimal for takeoff. The entire transformation from road-ready to flight-ready takes a mere 60 to 90 seconds. To put that in perspective, that's less time than you often spend waiting at a single traffic light. It's designed for seamless, intuitive operation, making the leap from asphalt to atmosphere incredibly efficient and user-friendly. Once you're airborne, the next layer of genius kicks in: Tesla's 3D autopilot. This isn't just an upgrade. It's a profound evolution of their already impressive full self-driving system, re-engineered for 3-dimensional space. This advanced AI takes over the intricate tasks of managing pitch, yaw, and altitude, ensuring a stable and controlled flight. You simply punch in your GPS coordinates, and the carplane's AI autonomously calculates the most efficient and safest flight corridor. It then proactively communicates with the local air traffic AI systems, coordinating its path, managing separation, and ensuring a smooth journey. Crucially, it automatically maintains a safe altitude, typically around 500 feet below any commercial jet airliners, keeping you out of their airspace and ensuring harmonious coexistence. But what about emergencies? Tesla has thought of that too. The vehicle incorporates comprehensive safety systems, including a full vehicle parachute, designed for deployment in extremely rare catastrophic scenarios. For less severe but still challenging situations, like an unexpected off-vertiport landing on uneven terrain, deployable crushable air pads are integrated under the belly, acting as intelligent airbags to absorb impact and protect occupants. The bottom line here is crystal clear. Tesla isn't just haphazardly stapling wings onto a sedan and hoping for the best. They are meticulously engineering and building an electric aircraft from the ground up, one that just so happens to fold back into an incredibly potent 1-second Euro 60 amp road demon the moment your wheels touch down. It's a truly integrated, dual-purpose machine. Section 2. What daily life looks like. Okay. We've delved into the mind-boggling specs, the intricate engineering, and the sheer audacity of the technology. But let's bring this down to earth, or rather up to the sky. How does this futuristic marvel actually change your mundane Tuesday morning, your weekend plans, or your overall quality of life? Let's run a couple of scenarios to really paint a picture. Imagine you're living the dream in sunny San Diego, but your high-powered office job is situated smack in downtown Los Angeles. Right now, that's a soul-crushing 3-hour bumper-to-bumper nightmare by car, often stretching longer on a bad day, or if you opt for a regional flight, it's still a 45-minute slog once you factor in the inevitable airport security, boarding, taxiing, and deplaning rituals that eat up precious hours. Now envision this with the Tesla flying car. You calmly drive out of your suburban San Diego garage, effortlessly merge onto the freeway, engage autopilot for the short ground segment, and then, with a tap, queue up a vertical takeoff zone on your navigation map. Maybe it's a repurposed parking structure at Qualcomm Stadium, or a dedicated vertiport on the outskirts of the city. The system, leveraging its sophisticated AI, books your slot, ensures the airspace is clear, and guides you through the seamless transition to flight mode. 25 exhilarating minutes later, you're gently descending onto the rooftop vertiport of a parking garage directly adjacent to your office building in downtown LA. Total commute time, door to door, a mind-boggling 35 minutes. You just clawed back 2 precious hours of your life every single day. Multiply that over a typical working year, and you're suddenly gaining back more than 21 full days, almost an entire month, of newfound freedom. Time you can dedicate to family, hobbies, personal growth, or simply more sleep. Think about the profound impact on your stress levels, your work-life balance, and your overall well-being. It's not just a faster commute. It's a radical reimagining of how we spend our most valuable asset, time. And it's not just weekdays that get a serious upgrade. Weekends, they become positively wild. Ever wanted to hit the slopes at Mammoth Mountain but absolutely dread the grueling 5-hour drive, often battling traffic and unpredictable road conditions? With your flying Tesla, that arduous journey transforms into an effortless adventure. You simply lift off from your backyard pad, yes, a small designated landing zone, perhaps, and cruise comfortably at 10,000 feet, enjoying breathtaking panoramic views, and then, in what feels like moments, you gently land at Mammoth Lakes Airport. Once on the ground, you seamlessly swap back to car mode for the quick 5-minute roll directly to the lodge. No TSA security lines, no frustrating baggage carousel waits, no agonizing rental car queues. Just pure, unadulterated travel freedom. But the benefits extend far beyond convenience. Because this incredible craft runs purely on batteries and not on expensive, environmentally damaging aviation gasoline, the operating cost is astonishingly low, roughly 8 cents per mile. That's cheaper than fueling most conventional electric vehicles on the road today, let alone a private aircraft. This cost efficiency makes aerial travel not just a luxury for the ultra-rich, but a genuinely accessible option for a much broader demographic. Imagine spontaneous weekend getaways, quick visits to distant friends or family, or exploring remote natural wonders that were once too cumbersome or expensive to reach. The world shrinks, opening up new possibilities for leisure, tourism, and personal exploration, all while being significantly more sustainable than traditional air travel. This isn't just about getting from point A to point B faster. It's about fundamentally reshaping our relationship with distance and unlocking an entirely new dimension of personal mobility. Section 3. Cities rewritten from the sky. Up now, let's zoom out a bit and consider the macro-level impact. When thousands and eventually tens of thousands of these silent electric vehicles begin humming overhead, our cities are going to undergo a transformation unlike anything seen since the invention of the elevator. That's right, cities will start to build vertically, not just upwards but in a truly 3-dimensional way. Expect to see vertiports sprouting up every few blocks, dramatically changing the urban skyline. These won't be your traditional helipads. Think of them as sophisticated multi-story hubs, essentially giant QR-coded landing zones that are seamlessly integrated with an overarching AI-driven air traffic grid. These vertiports will be designed for efficient, quiet, and rapid transitions, with automated parking and charging facilities. Urban planners are already anticipating this shift. We're seeing proactive changes in zoning laws in forward-thinking places like Dubai, Singapore, and even parts of Texas, all adapting to accommodate this new layer of aerial infrastructure. This isn't just about building landing pads. It's about redesigning urban arteries and flows for a skybound future. The economic implications for real estate will be profound. Properties located near these new takeoff and landing corridors, or with direct vertiport access, will undoubtedly skyrocket in value. Conversely, traditionally far-flung exurbs, once considered too remote for convenient commuting, will suddenly morph into highly desirable hot suburbs. Why? Because distance will no longer be measured in agonizing miles or minutes stuck in traffic, but in swift, efficient flight time. A 50-mile drive might take an hour and a half, but a 50-mile flight could be done in 15 minutes. This redefines the very concept of commutable distance and will spur new patterns of urban development and population. Distribution.urban planners are projecting a staggering 30% drop in ground-level congestion once just 1 in 20 commuters switches to aerial mode. Imagine that. Fewer cars idling, fewer traffic jams, and significantly reduced wear and tear on our roads. This translates directly into fewer potholes, less smog choking our city air, and remarkably quieter streets, transforming the urban experience for everyone, even those who never fly. The environmental benefits alone are immense, moving towards a cleaner, more breathable urban environment. Emergency services stand to win big too. Picture a paramedic crew, instead of being trapped in gridlocked traffic, effortlessly hopping over the congestion and touching down directly on the roof of a hospital in a third of the time it would normally take. This isn't just about convenience. It's about saving lives. Firefighters could reach inaccessible areas faster. Law enforcement could respond to incidents with unprecedented speed. And disaster relief efforts could be revolutionized by rapid aerial deployment. The ability to bypass ground obstacles will fundamentally alter the efficiency and effectiveness of critical public services. Financial institutions are already recognizing the monumental scope of this transformation. Morgan Stanley, a leading global financial services firm, estimates the urban air mobility market alone could reach a staggering $1.5 trillion by 2040. And Tesla, with its unparalleled first-mover advantage in electric propulsion, battery scale, and autonomous systems, is uniquely positioned to lock in a dominant, perhaps even controlling slice of that colossal pie. This isn't just a niche market. It's a burgeoning industry poised for explosive growth, and Tesla has all the ingredients to lead the charge. Section 4, Challenges. Nobody skips, of course. It's not all clear blue skies and effortless flight. Every revolutionary technology faces its gauntlet of challenges, and the flying car is no exception. In fact, some of these hurdles are monumental, requiring not just technological innovation but also a complete rethinking of existing frameworks. The biggest boss fight, arguably, is regulation. Our current regulatory bodies, primarily the Federal Aviation Administration, FAA, in the US and its global counterparts, were simply not designed for a future where personal autonomous aircraft are a common sight. They need entirely new licensing classes, something that bridges the gap between a standard driver's license and a full private pilot's ticket. This isn't a simple tweak. It's a wholesale reevaluation of pilot training, certification, and ongoing proficiency. Experts anticipate that operators will need somewhere between 20 to 40 hours of mandated flight training, coupled with extensive simulator time, to qualify. Tesla, ever the disruptor, says it believes it can compress this intensive training into a highly efficient 2 to 3 month evening course, likely delivered through its innovative app-based academy. But even with streamlined training, you still have to pass the rigorous tests and demonstrate competence. Beyond individual pilot licensing, there are massive challenges in establishing new air traffic control protocols for low-altitude urban airspace, developing new safety standards for eVTOL, electric vertical takeoff and landing vehicles, and creating liability frameworks for autonomous aerial operations. The regulatory landscape is a complex, multi-layered puzzle, that will require unprecedented collaboration between innovators, policymakers, and public safety advocates. Then there's the critical issue of noise perception, and perhaps more broadly, public acceptance. Even though Tesla's electric jets are engineered to be whisper quiet, operating at around 65 dB, which, to put it in perspective, is quieter than a typical garbage truck, the phrase flying car conjures up very different images for many people. Their minds immediately jump to the cacophony of Vietnam-era choppers thumping menacingly overhead, or the loud buzzing drones that are common today. Overcoming this ingrained perception will be a massive undertaking. Extensive public acceptance campaigns will be absolutely huge, focusing on educating people about the actual sound profile, the safety features, and the myriad benefits. It will require demonstrating repeatedly that these are not loud, intrusive machines, but rather quiet, efficient modes of transport, designed to integrate seamlessly into urban environments. Visual demonstrations, public test flights, and transparent communication will be key to shifting public perception from skepticism to enthusiastic adoption. Weather is another undeniable reality check. While these sophisticated craft will handle light rain with ease, thanks to advanced hydrophobic coatings that repel water, you are absolutely not going to be flying through a thunderstorm. Autonomous systems will be programmed with strict weather parameters, rerouting you around inclement conditions or, if necessary, grounding you entirely for safety. This means that while much of your travel will be frictionless, there will still be days when ground travel is the only option, or when your flight path is altered. This is a practical limitation that must be honestly addressed to manage expectations. Battery degradation is also a more significant concern in flight than in ground vehicles. The discharge rates required for vertical takeoff and sustained flight are brutal on battery packs, far more demanding than even aggressive driving. This intense usage accelerates the natural degradation process of the battery cells. Tesla is addressing this head-on by likely warrantying these packs for around 1,000 cycles, which translates to roughly 600,000 miles of flight, or even more for ground operation. This warranty provides peace of mind, but it also highlights the engineering challenge of ensuring long-term battery performance under such strenuous conditions. Advanced battery management systems, sophisticated cooling, and robust cell chemistry will be vital to maximizing pack life. And of course, the elephant in the room, the price. Let's be realistic. Early adopters, those who simply must have the latest and greatest, can expect to pay somewhere in the ballpark of $200,000 for the initial Signature Series models. These will be the premium, fully loaded versions, catering to a market segment willing to pay for exclusivity and cutting-edge technology. However, Elon Musk, ever the visionary focused on mass market adoption, has hinted at a future standard model that could retail for as low as $50,000. This dramatic price drop, however, is contingent on production scaling past 100,000 units annually, leveraging Tesla's renowned manufacturing efficiency and economies of scale. The journey from a niche luxury item to a more accessible mode of transport is a familiar Tesla playbook, but it will require massive investment in gigafactories and a robust supply chain to achieve. Section 5. Why Tesla pulls ahead. When you look at the burgeoning eVTOL market, you see a landscape dotted with innovative startups. Companies like Joby Aviation or Lilium are indeed developing slick prototypes, showcasing impressive engineering and bold visions. They're making significant strides, but here's the critical differentiator. None of them, not a single one, can come close to matching Tesla's integrated ecosystem. This isn't just a minor advantage. It's a colossal, almost insurmountable lead. Let's break down why Tesla is positioned to dominate this space before it even fully blossoms. First, consider the charging infrastructure. Tesla's supercharger network already blankets vast swathes of the globe, a testament to years of strategic investment and expansion. This isn't just about cars. It's about energy distribution. Imagine retrofitting these existing supercharger stations with $350 megachargers, the kind of ultra-fast charging required for these larger, more energy-intensive flying vehicles. Suddenly, you have a ready-made network of charging points for flying cars every 150 miles or so, seamlessly integrated into our existing infrastructure. Startups, by contrast, are faced with the daunting, capital-intensive task of building their own proprietary charging networks from scratch, a hurdle that could take decades and billions of dollars to overcome. Tesla's existing energy infrastructure provides a foundational advantage that simply cannot be replicated overnight. Second, let's talk about artificial intelligence and autonomy. Tesla's vehicles have collectively racked up billions of real-world road miles, generating an unparalleled dataset of driving scenarios, unpredictable human behavior, and environmental conditions. This isn't just data for ground vehicles. It's a foundational understanding of real-world physics, sensor fusion, and predictive modeling that can be directly ported and adapted to 3D airspace models. Tesla's AI has been trained on a scale that no aerospace boutique can touch, giving them a significant head start in developing the sophisticated 3D autopilot necessary for safe, autonomous flight. The algorithms for obstacle avoidance, path planning, and even predicting potential air traffic conflicts can be refined much faster with such a vast data foundation. Third, the manufacturing prowess. Tesla's gigafactories are marvels of modern engineering, cranking out battery cells and entire vehicles at a cost and scale that smaller aerospace companies simply cannot compete with. The ability to produce high-performance 4680 cells in such massive volumes drives down costs significantly. This vertical integration from raw materials to finished product gives Tesla an inherent cost advantage that will allow them to offer their flying cars at price points that others can only dream of. Startups often rely on third-party suppliers for components, adding layers of cost and complexity. Tesla controls its destiny, from battery chemistry to final assembly. Finally, consider Tesla's unique business model. They don't just sell cars, they sell energy, storage solutions, and recurring software subscriptions. This multifaceted revenue stream allows Tesla a strategic flexibility that pure hardware manufacturers lack. They can, for instance, subsidize the sticker price of the flying car, much in the same way they made the Model 3 accessible, by offsetting initial vehicle costs with revenue from charging networks, software upgrades, and even future aerial ride-sharing services. This financial flexibility means they can aggressively price their vehicles to capture market share, while still maintaining profitability through their integrated ecosystem. In short, the same powerful flywheel effect that enabled Tesla to slash the costs of electric vehicles and dominate that market is now poised to undercut the emerging eVTOL market before it even has a chance to fully blossom. It's a systemic advantage, built on years of innovation, infrastructure development, and a relentless focus on vertical integration and cost efficiency. Conclusion: your skybound future. So, how will Tesla's flying car truly transform everything we know about transportation? It's not just about speed. It's about fundamentally deleting distance, effectively shrinking our world. It's about giving you back precious weeks of your life every single year, reclaiming time that was once lost to soul-crushing commutes. And it's about redrawing our city maps, not just across 2 dimensions, but by integrating a vibrant, efficient third dimension of movement into urban planning. Commutes will shrink to exhilarating short hops. Real estate values will shift and redistribute in fascinating new patterns, and our collective carbon output will drop significantly as the era of burning jet fuel for routine 200-mile journeys fades into obsolescence. Yes, there are undeniable hurdles. Rules need to be rewritten, new regulatory frameworks must be established, and public nerves understandably need calming through education and demonstration. But let's be honest, Tesla has already steamrolled over far bigger obstacles in its relatively short history. If history is any guide, and it usually is, the early skepticism and the "it'll never work" crowd will look utterly silly in hindsight. That day will come when your neighbors casually hop over rush hour traffic at a serene 248 miles per hour, making their way to work or a weekend getaway with effortless grace. Keep your eyes firmly fixed on 2026. That's when the sky stops being a distant, unreachable limit and starts becoming your everyday, open-access shortcut. If you found genuine value in this deep dive, if your imagination has been sparked, then please drop a like, smash that subscribe button, and share this with that one friend who still stubbornly believes traffic is just part of life. Together, we'll track every single update, every breakthrough, every new development until the glorious day we can all confidently punch flight mode on our dashboards and never, ever look back. Thanks for watching, and I'll catch you in the air.